Now how do I, wait, rats, I hit the wrong button. Okay, for today, we're going to start off with just a little tiny bit of review. I know hopefully you, like me, are just going to see right away, oh, -5 and 4. But the answers aren't -5 and 4. They're either what's between them or what's outside of them. Would you please make a number line and figure out for me whether it's what's between them or what's outside of them by testing some points or by graphing it. Graphing it would totally work. I'm going to pause for a second while you see if you remember how to do that part. Okay, so here's how I would think about it. All right, I guess I better test the intervals. Maybe I'll try a spot in here. I'll change colors just to show you what I'm doing with a different color. Maybe I should test 0. Seems like a good idea. Put in 0 and 0, and I get 5 times -4 is -20 is bigger than 0. It's not. So that's out. So then it's probably on the outsides, but I better test a number at least. I'm going to put in a 5. If I put in a 5 here, 5 here, then it's going to be 10 and 1. 10 times 1 is 10. Is 10 bigger than 0? Oh, yes, it is. So it's probably shade on the outside of those. Now, I'm going to just do a quick sketch of the graph and go, oh yeah, this is a parabola that goes through here. And then it's where is the parabola above 0? So that makes sense. It's on the outside. So -infinity to -5. And you could do all that work and screw it up right there. What did I just do wrong?
You put a bracket.
I put a bracket. Why should I not put a bracket? Because it's not or equal to. If this had said an or equal to right there, then I would you need a bracket, but I don't. So it's a parentheses. Union with 4 to infinity. There you go. Now, take example 2. See if you'd pass that one. These are easy. These are supposed to be easy. I get you're still in the learning mode, and we aren't testing until next week. But you should have a pretty good chance of getting this one right without any extra help. If it had been equal to 0, you did this last year. I hope you know that you can factor it. You should, but you can't factor it. So how are you supposed to solve it then? Graphing would totally work, but could there be another way? Quadratic formula. Either one works. And remember, you have a calculator, and therefore it's totally fine with me if you use your calculator at this point. One last thought on that. If you're going to use the calculator, it'd be y equals this and also y equals 0. And think of it as 2 separate things. Because then when this changes to like, oh, absolute value of 4, you can still kind of roll with it. You're graphing both sides of the equation. And the other side is just y equals 0. Yeah, I know it's the same as the x-axis, but it also allows you to use second calculate intersect on your calculator. So I'm going to back up a little bit and go back to there. Now I see a lot of people grabbing their calculators. If you have trouble seeing it, try zoom 6. That gets you into a more normal zoom. If you still can't see it after hitting zoom 6, then maybe you zoom out a little bit till you can see what's going on. Now if you're using the calculator to grind out your numbers for the quadratic formula, it's totally okay. That will work. Apparently I'm going to pause for a second. Okay, so I was asked the question, once you do know what the two numbers are, some weird decimals probably because it's something coming out of quadratic formula, so then how do you know whether it's between them or outside them or what? Well, really the easiest way to answer that for me is to say, test the intervals. Pick a number, stick it in, see if it works or not. But I also want you to think about what it looks like. We're very visual people, and I bet you once I draw this in here, I know it's a right side up parabola. It has to be. Then when is the parabola less than 0 now that you see the picture? Can you tell it's when it's between the two numbers that the parabola is less than 0? Yeah. When would it ever have been this way? If there'd have been a negative in the front, it would have been that way. So I can tell just by doing that I think that the answer is between the two strange numbers I'm going to get from the quadratic formula. Okay, but if I wanted to be sure, I'd pick a number between those two numbers, and I would stick it in the equation and make sure it works. So double checking is one of my themes. I encourage you, since you only have 4 R3s, that you take a second to check them on the test. How could you check them? You could try it one way, graphing it, and you could try another way, sticking in a point. And if they disagree, you'll be like, uh-oh, I'm doing something wrong. At least you'll know that something's messed up. Okay. Wow. Okay. So people that use the quadratic formula to do this, can somebody tell me what you got when you put in x equals negative b, which is 5 plus or minus square root of b squared, which is 25, minus 4ac, 4 times 1 times negative 3, all over 2a, which is 2. All right, how about this? I asked my question and I made it too long, so I didn't get any response. You, Miss L, can you tell me what you got for the 2 roots?
I'm going to round.
It's okay if you round.
X equals 5.54.
5.5, and what's the other one?
Negative 0.5.
Negative 0.5 and positive 5. Is that rounding maybe too far? I don't know. About 5 and about negative a half? All right. Could I have gotten that with a graphing calculator? Yes. I would have graphed it, and I would have done second calculate intersect to see where the 2 crossed. All right. So there. Okay. Sorry about that. So now how do I make the final call? I'm testing something between negative 0.5 and positive 5, and 0 is always a nice number. Do you get if I put a 0 in, these two parts will cancel? And then it'll just be negative 3 is less than 0, which seems true to me. So I now know for sure it's in between them. Okay? If it was above 0, then just think of it as, did it make the equation work or not? If it came out above 0, then that would be false, so it didn't make the equation work. What you're trying to do is find values that make the equation work. All right. Okay. So that's a review to kind of catch you up to where we're supposed to be today. Now, let's take a moment, and we're not making dots. You are going to be doing regression kind of like this, except I don't want to take some boring energy from the 1950s numbers. I want to do some data in the classroom here. So we're going to make a little chart like that. Everybody go off to the side, and we're going to do pinky length, and we're going to do height. And we are going to do a correlation of those two. Your pinky length versus your height. Now, only people that know how tall they are should participate, because if you don't know how tall you are, then I can't get your height part, because I'm not going to be able to measure you accurately with this stick. I'd have to like move it twice. And so bottom line, I only need like 5 pieces of data. So is there 5 kids in here who know how tall they are and are willing to be measured? Awesome. And I'm going to have you hold out your pinky, and I will measure from the base of your pinky in inches, and then you're going to tell me how many inches tall you are. Inches. Oh, wait, yeah, here's how you do that with feet and inches. There we go. Your pinky is 2.7 inches. Wait, let me try one more time, because I got to measure from the base of your pinky. Okay, no, 2.6. Your pinky's 2.6. Now, that's inches. Everybody write that down. 2.6 goes with, now, if you need to tell me in feet and inches, you can, but you can just take your feet, times it by 12, and then add inches. What did you get?
66.
66. All right. Somebody else.
5'6".
Pop out the pinky. All right. Yours, without the fingernail, is 2.4. And?
I'm 62 inches.
Look at that. The height was smaller and the pinky was smaller. That makes sense.
Wait, what is
It's up on the board there. All right. Ready?
One of my pinkies
Oh, wait. Wrong end. There. Can you slide your pinky out a little bit? So there you go. Good. 2.75. And your height, sir?
5'9", would be 69.
So 2.75 and 69. And that makes sense. It was a longer pinky than we had, and we had a higher height than we had. All right. I see another couple pinkies being raised over here. All right. Ready? And you are at 2.6. And this is interesting because your height is almost guaranteed to be different than this other person. What's your height in inches?
5'11", or
So 5'11", so that would be 71. All right. Now look at that. We had a 2.6 before and it was a 66. Now this is a 2.6 and it's a 71. That just shows you that the real world is messy. It's not super perfect correlation. All right. Let's try this one. Can you move your pinky? There you go. Perfect. And you have a 2.6. It's another 2.6. And how about your height?
68.5.
68.5. Now we have three pinkies that are the same length and different heights. All right. Your pinky length, 2.7, no, wait. 2 point, let me think, that's 2.75. 2.6. So 2.6, a third 2.6, this is getting weird. Or fourth 2.6. And what did you get for a height? You know your height? You just wanted to know your pinky length, didn't you? You bum. All right.
How tall are you, Molly?
No, I didn't. Except it's on the video that I did, so I guess I did. 2.5. 2.5, and we have a 66. So 2.5, change that one to 2.5 and a 66, because I can't take the pinky length without the height. All right, how about you? Tallest kid I've measured, I think. Ooh, look at the size of that pinky. 3.1. Dang. And height, sir? I gotta find this out. I was just figuring it out. He knows what his feet in inches is. He's just trying to figure out what that equates to. I'm gonna guess 70 something. 74. 74. 3.1 goes to 74. Okay. All right. Good enough. We have enough data. Now, I'm going to give you a morbid reason that this is sometimes necessary. Imagine for a moment you're in Hawaii and you're out, like playing around on the beach, and all of a sudden an arm washes up. There. Then you'll be able to tell from the length of their pinky how tall they should be. There are charts for that. Okay, so they have charts that have been made just like we're about to do this that'll tell you, okay, turns out that the pinky was 3.5 inches long. And I can already tell, dang, they're pretty tall. You know what I'm saying? Without this chart, I wouldn't have known that. But now we're going to get exact numbers. So everybody now, this is the part where you grab your graphing calculator. And those that are following along at home, you really got to listen close as I tell you exactly what buttons to push. I wish I could show you on the screen, but I can't. So you just have to look close. All right, first thing we're going to do is hit the Stat button. And the thing that comes up after Stat is Edit. The first thing that pops up is Edit. Does that kind of imply to you that they think you're going to probably want to do that? Yes. So you hit Enter again, and you're in the Edit mode. And now you go to L1, which is List 1. And List 1 is where we're going to put all the pinky lengths. L1 is here, and L2 is the heights. So this is the part where you just type all of them in. In L1, you're going to type in all these numbers. In L2, you're going to type in all these numbers. All right. I'm going to pause for a minute to help some kids with tech issues. So, you have done Stat, Calculate, Linear Regression, L1, L2, And if your calculator is one of the old calculators and you don't have a list like that, yours just says lin reg, raise your hand now. If you're one of the people that has the old calculator, it just says lin reg. Okay, so then what you guys do is you type in L1, by the way, it's above the 1 key, comma, which is above the 7, L2, which is above the 2 key. Okay, so now you got lin reg L1, comma, L2. Then everybody goes to calculate or hits enter, and it spits out an equation. Would you tell me what it says exactly? It says y equals what? AX, something like that? AX plus B. And then underneath that it says, oh yeah, you probably want to know what A is. What's A?
70.31.
70.31. Okay.
That is
Oh,
not what I got.
okay. Now what that means is you probably typed in one number wrong. So go back to your stat edit in your list, and that means you probably have one
I
number
got-
wrong on the list.
You probably didn't put a decimal point.
Yeah, I was so confused.
It's 14.8.
Oh my gosh, I put all these 14.84.
Okay, thank you. 14 point what?
84.
All right, so we're gonna go with 14.8 is close enough. Unless, would it round to 14.9?
No.
Okay, 14.8 for our A. And what's our B?
28.8.
28.8. Would it round to anything?
That is rounded to
That
8.
is rounded? Okay, good. Okay, then let me strongly encourage you to actually write it out as its complete equation. 14.8x plus 28.8, because that's what we would ask for on the test, is what is the linear regression equation? And you'd write out y equals 14.8x plus 28.8. What does this thing do? Well, it relates pinky lengths to heights. And so, let's be morbid again. You've been swimming around on the beach, you find this pinky, and this pinky is 3.5 inches long. Did I just give you an X or a Y?
X.
Yeah, because the 3.5 would go here, and that's part of the X column, the L1 column, and yes, that would go here then. Everybody take a second, put it in your calculator, and let's see how tall this person was.
How long was it?
3.5. What'd you get for a height? A Y equals 80.6. Now let's convert that into feet, because anybody who's on the news isn't going to be saying, look for an 80-inch tall person. People would be like, what?
6'8". 6'6".
Which one is it? 6
6 foot.
foot
7.
7. Right? So 6 times 12 would be 60, 72, 6 foot 8, isn't it?
Yeah, 6 foot 8.
Okay.
6.7.
6 times 12 would be 60, 72. 72 plus the 8 would make the 80. So that's a little over 6'8", actually. So we're looking for a professional basketball player, clearly, who was out surfing and was eaten by a shark. It's possible. That'd be a really big shark to eat a 6'8" person, but
I feel like they'll round their height up.
you got a point. We could technically have rounded this to a 6'9" person. All right. Whales don't eat people. Okay. One more tweak. What if the question, to just make it more honors pre-calcish, because that was a little too easy, what if they said, the person that was involved in the industrial accident was 5'11", and they're wondering if you would keep an eye out for a pinky that is approximately how long? All right, so the person was 5'11". You can figure out how many inches that is. I'll give you a good story. I'm going to pause just because I can't control who's listening at home. Could be little kids involved. All right, so here's what you should have done. We have this same equation, except now this time we're going to put in 5'11", which you can't put 5'11" here. It doesn't know what you were saying. You got to change that into feet and inches, right? So 5 times 12,
60.
60 plus the 11. 71. Did you put in a 71? Or is that the problem? Wait.
11 times 12.
Okay, 5.11 is not 5 foot 11. Okay. I do get what you were saying, but... All right, 71 equals 14.8x plus 28.8. And then you solve for x. Tell me, sir. Take 71.
I got 2.8.
Oh, you already got it? And a lot of people got that. 2.85. After you subtracted 28.8 and then divided by the 14.8, you should have got 2.85, and that seems logical. All right, one more thing that freaks people out a little bit. Remember, if we put in a 66, even our own data is all over the place. A 66-inch person had this and this, a 2.6 and a 2.5. So how do we know which it's going to come up with? It's very likely it'll come up with neither one of them. Your formula can't go through all the points. So let me show you what it would look like. You have a whole bunch of dots that generally are on a straightish line. And then what you just found was called the linear regression equation. It's also called the line of best fit. Do you remember doing a line of best fit before? All right, you probably did at some point. Now, you probably never used a calculator to calculate the linear regression, but that's what you just did. All right, what happens next in honors pre-calc is we go, okay, now our data happens to not be a straight linear equation. Our data is quadratic. Is there anything in the real world that does that? Yes. There are things where you have the data that changes and goes down at first and then comes back up again, and that's quadratic data. So then there's quadratic regression. There's cubic regression. There's all different kinds of regressions. Okay? The one you just did, straight line, is the one that makes the most sense to people. You understand, oh, taller person, longer pinky, makes sense. But you don't have that all the time. Sometimes you have this quadratic situation. All right. So let's actually assign you some problems that are like this. Let's go find the first one that's actually in the homework section right there. This one.
But I
Can't see what's up there?
Oh no, you're kind of.
I'll move. All right, 5.51 exercises, and you are doing this one, which you're going to require to... Wait a minute, the chart's going sideways. What's going on? I can't adjust. Oh, well, maybe you can. X and Y is like L1 and L2. It's not that scary. And how would I know that for sure? Well, time is always your X because it's supposed to be independent. In case you had forgotten, the independent variable goes down here and the dependent variable goes here. Independent things are like things that don't depend on anything else. Does time depend on anything? Well, technically it does. Depends on how much gravity is around. Did you know that you can actually change or bend time? You can. Things like wormholes, things like black holes can mess with time. And the movie Interstellar does a good job of showing that example. Okay. So anyway, time is normally independent. And dependent is often, well, it can be a lot of different things. Oftentimes it's money, because money totally depends on the situation. How much is that car worth? Well, it depends. Is it brand new? Has it been used even for a week? If it's been used for a week, it's worth less. Maybe the car's got $1 million in the trunk. What's it worth now? Was the car owned by James Bond in one of the Bond movies? Then holy crap, the value just doubled or tripled if it was driven in a movie. The Batmobile wouldn't have been worth that much, except it was actually in the movie Batman, and so it was made it worth way more. So it all depends. Money is dependent. Okay. So anyway, if you're going to do this problem, I don't think you need too many like this. We're going to do one more like this, and it's the next one. We are in the 12-minute warning mark here after all. And we're going to do one more question after that. Just one more little problem. Not this one, though. Only this one. Problem 5. And I know it's got 3 parts, but you've got a graphing calculator for Pete's sakes. And these are graphing questions. So this will just help you remember how to use your graphing calculator. And I don't need you to graph every single point that is on this. If you got a few points right and then sketch it in there, I'd be good with that. All right, so that'll help you remember how to use your graphing calculator. So that's what it's all about today, is reminding you how to use the graphing calculator to do, well, and making a new one, the stats regression equation that we just did called linear regressions. And then from now on, just be conscious that you have a calculator and you can use it on every problem of the homework and of the test. So, you know, use it when you can. Okay, so that's a fairly reasonably sized assignment, and I guess the rest of the time is yours.